So you might be wondering, is there a shortcut here? And your hint is to look at these integral limits. What do they tell you when you have something like negative a to a? Do you know of any properties? And if you don't, we're going to get into that, but also take into account the fact that we've got two trigonometric functions here. Now, in case you don't see the shortcut yet, let me remind you of the following. Do you remember that for an odd function, if you plug in negative x, wherever you see x in the original function, if the output is -1 times what you started with, it's odd. And then we also have this other property here for even functions. Now, a question for you is, what can this tell us? If we can prove the integral is either odd or even, can we use any special rules about integrals? So I'll get back to that. What I'm going to start out with doing now is I'm going to actually take the original problem and split the numerator. So that way we have two separate integrals here. And for this left one, I'm going to label it g of x. And for this right one, I will label it as h of x. Now, why am I doing this? Well, if I want to prove that something is even or odd, it just looks easier for me on the numerator to only have one trigonometric function. So starting with g of x, wherever I have an x now, check this out. I plug in a negative x, and then after I simplify this, does it tell me anything? Well, if you remember, the sign of negative x is the same as negative sign of x, right? We have that special trigonometric property. So looking at this, it looks very similar to g of x that we started with, right? The only difference is you've got this -1 in front. That tells us that g of x, that left integral, is an odd function. So I hope you're starting to see where I'm going with this. And now I'm going to work with the other integral that I had labeled h of x. And what am I going to do here? I'm going to plug in negative x, again, anywhere I see an x. Now this one looks a little hairier, but it's not too bad. So after I simplify it, I'm going to get this expression here, because we know cosine of negative x is the same as cosine of x. And so looking at this compared to h of x, what do we see? Well, again, we have this negative in front, and we again have an odd function. So circling back to the question I had for you, can we do anything special now, knowing that our original integral is the sum of two smaller integrals where each one of those are odd functions? Well, there's a special property of integrals that are symmetric, where for an odd integral from negative a to a, of a symmetric function like what we're dealing with, this is actually 0 for the area under the curve. And now that tells us that our final answer is 0 plus 0